we are trying to graph this function. By the way, this is going to be a hyperbola because the question asks us to find the transverse axis. Only hyperbola has the transverse axis. Right. So from that equation, we're going to turn this into the standard form. This one we have y squared is positive and then x squared is negative. So that will be y minus k squared over a squared minus x minus a squared over b squared equal to 1. To do this, we're going to do the completion square and try to turn this equation into that form, and only then we can find the information about the graph, about the function. So we start with y squared minus 10y and then minus 25x squared minus 200x, and the 400 I will put on the other side of the equation. Put 400 here. Right. So what we just did, we put y together, x together, and the number on the other side. Next we'll do the complete square. We're going to add something on both sides to complete the square for the y. So we're going to add something here, and we're going to add something for x as well. But before we do that, we're going to factor the negative 25 out, and then we will have x squared 200 divided by 25, that is 8. So we plus ax, and we're going to add something to it. Right. And on the other side we have 400. Now if we add something to this side, we have to add something to the other side. That one is perfectly fine. This one, if we add something on this side, we're going to add something on that side as well. Just watch out for the negative 25 in front of it. That might be a problem. And to do the completion square, we take half of the middle number here, and we do half of that number, that is a half, and give us 5. And then we want to square it. So we take half and then we square. Square 5 is 25, so we're going to add 25 on this side and 25 on that side. Right. Next, do the same thing. Take half of this number and then square it. So half of it, and then we square. Half of 8 is 4. 4 square is 16. And so, but this time we add 16. We don't put 16 there because we add 16, but we have to multiply by negative 25. So 16 times negative 25 is minus 400, and that's what we put on the other side. And so 400, negative 400 cancel out. And to simplify this, the equation will be, now we have the square for y, the square for x, still negative 25 in front of it, and there will be 25. Right, here we have y squared, so it's just y, and that's the minus, and this is x, but that's the plus. So we have this form. To go to the standard form, all we need to do is divide everything by 25. So the right hand side is going to be equal to 1. So we will have y minus 5 squared over 25 minus x plus 4 square. We can say over 1, that equal to 1. Just say that equal to 1 over 1. Right. So that is the equation of the ellipse. We can get all the information about the ellipse with that equation. From here we can say that the center compared to the equation k is equal to 5 and h is equal to -4. So the center h and k -4 and 5. -4 and 5. So that is the center. Next, we will find all of those information later. But first we look at the graph. We see that 25 is below the y and the 1 is below the x. We're going to take the square root of that. Square of 25 is 5. So meaning that from this point we go up 5 units and down 5 units. So look at the graph first. So we'll go 5 units up. From 5 it's going to be 10. And 5 units down, so that would be 0. And then 1 below the x. Square root of 1 is still 1, so 1 left and 1 right. So I'm going to draw a rectangle here. With this box, it would be a lot easier to graph the hyperbola. So again, 5 up, 5 down, 1 left, 1 right. With that, we can draw the diagonals. This will be the asymptotes. Just do that green. So we're going to have the asymptotes. And we know that this hyperbola will go with y square and then minus x square. So this will open up and down. So the sketch of the hyperbola will be like this. So from the vertex, it will touch that box and it will approach the asymptotes. So the graph is actually easier to graph than to find the other information. We know the center is -4 and 5. That's the first thing. Next, because it opened up and down, the transverse axis is going to be this line, and that is parallel to the y-axis. So we write the first one is the center. Next, the transverse axis is parallel to the y-axis on the line x equal to 0. So next we need to find the vertices. The vertices is where the hyperbola touch the box. So here we see 1 point here, 1 point there. We actually can find the coordinate is -4 and 10 and -4 and 0. But we can spin off here. This is going to be the vertical hyperbola. So the first component, the x coordinate, will stay the same. So it's going to be -4. Since we go 5 up and 5 down from 5, add 5 to it, we have 10. Minus 5 from it, we have 0. And that will give us the vertices. So we say vertices. We start from, we can write the formula too, but h still stay the same. K, we're going to plus or minus, we're going to go up and down 5 units. That is A, by the way. So we can say from this equation A is 5 and B is 1 if we want to stick with the formula, but in this case let's just use the formula. It's going to be A, but we just say negative 4, 5 plus or minus 5 give us 2 points, negative 4 and 10, one vertex, and negative 4 and 0 the other vertex. Right. The foci. Since the graph open like this, the foci is where the graph go around it, so the foci is somewhere in here and somewhere in there. Might not be exact, but you get the idea. So from that point, the distance from a focus to a center is going to be c. So we can say Pythagorean theorem here. We say a squared plus b squared equal to c squared. So we have a and b, so we can say c is equal to square root of a squared plus b squared. A is 5 and b is 1, so 5 squared, 1 squared, so square root of 26. So the foci, seeing it is vertical, the x component stays the same. Only thing that changes is we go from k up c unit and minus down c unit, so plus or minus c. In our particular problem, h is negative 4, 5, we go up and down square root of 26 unit to get to the focus. So that is the foci. Those are the foci. And then we just need to find the asymptotes. We know the asymptote already, we just need to find the equation. So the equation of the asymptotes, let's say it in green then. For the asymptotes, we know that the equation is, in general, of any line is y minus y1 equal to m x minus x1. So in general, the equation of a line that has the slope m and goes through the point x1, y1 is going to be this. We know that it is going to be equal to the y1 is going to be it goes through the center, so y1 is pretty much k, and k is 5, so it's going to be y minus 5. And it has two asymptotes with positive and negative slope. I will worry about the slope later. For now, we're going to have x minus x1. X1 in this case is h, so it will be just plus 4. So pretty much we have the x plus 4 and the x plus 4 here, and the y minus 5 and the y minus 5 here, pretty much just like in the equation. Now the slope, it should be easy. The slope is rise over run. We go 5 units up and 1 unit to the right, so plus or minus 5 over 1, rise over run. And to simplify this equation, we have y minus 5 equal to plus or minus 5 x plus 4. If we do the plus sign, we will have y equal to 5x plus 20, and then we plus 5 on that side. So the equation is y equal to 5x plus 25 is one of the asymptotes. And the other equation is where it is with the negative slope, negative 5x, negative 20, plus 5. So we have y equal to negative 5x, negative 15. And so we have two asymptotes. Right, let me zoom out to see the whole problem. So when we have the equation, we have to know where the center. That's where we start. And I just look at the formula. If we go up and down 5 units, I don't worry about A and B yet. 5 units up and down, 1 unit left and right. We draw the box. With the box, we have the diagonals, and that is the asymptotes. Once we have the asymptotes, the vertex, the parabola will go approaching to the asymptotes and touch the edge of the box. We know it's going to be y squared minus x squared, so it's going to be vertical. So it will touch the upper edge and the lower edge. And we have the parabola. From that, we can determine the transverse axis. The vertices, in this case, from the center, go up and down. The foci, same way, from the center, go up and down. And the asymptotes, in general, is going to be in that form. And y minus 5 and y minus 5 the same in the equation. X plus 4 and x plus 4 the same equation. In the equation of the ellipse, equation of the hyperbola and the equation of the line are the same. The slope rise over run, and that's what we have.